Here's an example of a mutually exclusive problem. So let's pretend we have a deck of cards. And we're talking about event A. Being the aces in the deck. So we notice here are the 4 aces in the deck. And event B, kings in the deck. There are 4 kings in the deck. So we're going to first find out what is the probability of a card being a king and an ace. Well, these are considered mutually exclusive because you couldn't have a king and an ace. If you look at this, it wouldn't make sense. You either have one or the other. So the word "and" tells us that the probability would not happen to have a king and an ace. The probability would be 0. Now, let's change the word from an "and" to an "or." So find the probability of the card being a king or an ace. So let's talk about first the king. So the king has 4 in the Venn diagram out of a total of 52. So you have a 4 out of 52 chance of getting a king. We reduce that down, you have a 1 out of 13 chance. Now let's talk about the probability of an ace. You also have 4 in the deck out of 52. So you have a 4 out of 52 chance, reducing it down, a 1 out of 13. Now we're going to go ahead and use the equation that we learned. To find the probability of a king or an ace, you take the probability of the king plus the probability of the ace. So you have a 1 out of 13 plus a 1 out of 13 chance. So you have a 2 out of 13 chance of getting the probability of being a king or an ace. So if you want to note notation, king or an ace, that's your notation of "or."